Hello everyone, good afternoon dear authors and invited guests. Welcome to technical session 11C. Myself Karthik Bharadwaj and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Solistic LLP, it's my great pleasure to welcome you to the 10th International Conference on Smart Trends in Computing and Communication, SMARTCOM 2026, Pune, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is held yesterday in Pune, India, and the virtual event is being held through Zoom from 19th to 21st of January 2026. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for their presentation and 2 minutes for question answer. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remark. If you have any query or update, you can write it to me in the chat box. Just before we get started with the session, I'd like to introduce you with today's session chair, Dr. Ganesh. Dr. Ganesh is an associate professor at Vardhaman College of Engineering, Hyderabad, India. He is active member of Soft Computing Research Society and is listed on Google. I request our respected session chair, sir, to address our participants.
Am I audible?
Yes, sir, you're clearly audible to us.
Yeah. First of all, thanks to organizer, give me opportunity as a session chair. So, from this onwards, we are going to start all the session as per the Karthik said. All the information already given to you people. So I say best of luck, everyone. Keep it up.
Thank
Yeah.
you, sir,
Over to
for such
Karthik. Yeah.
motivating words.
Yeah.
Now we will be starting with our first presentation of the day. For the first presentation, I like to invite presenter Praharsh for the paper title A Comprehensive Review of EEG based Brain Computer Interface Systems. I request presenter to kindly proceed with their presentation.
Good morning, sir. So I'm just facing a few webcam issues. Will it be okay if I can get a little bit of time to check that out? Or
Uh, it is not important, or like it is not necessary to turn on your camera. If you can proceed, it will be okay.
all right, sir. Thank you. Just one second. So good afternoon. So am I audible?
Yes, sir, you are clearly audible to us. Please share your screen.
Yes. Just one second.
So, is there any problem? The participant is facing some network issues. Till that, let's move to the next participant. For the next presentation, I like to call presenter Satish S for the paper title A Systematic Review of AI Driven User Authentication, Modalities, Performance, and Privacy Implications. I request the presenter to kindly proceed with their presentation.
Yeah, good afternoon, everyone. Am I audible, Karthik?
Yes, sir, you're clearly audible to us.
Yeah, my screen visible?
Yes, sir, it is clearly visible. Please proceed.
Okay, thank you. So, myself, Dr. Satish Banait. I'm going to present paper. The topic of my paper is Systematic Review of AI-Driven User Authentication, Modalities, Performance, and Privacy Implication. Okay. Now, if we're talking about the problem statement, so about this research paper, the traditional authentication methods like password, PIN, tokens are increasingly vulnerable to phishing and credential leakage. So static knowledge-based authentication file fails to adapt to evolving user behavior. Rapid growth of user service demands stronger security, better usability, and continuous authentication, as well as AI-driven authentication promises improvement, but lacks standardized evaluation raises privacy bias and deployment. Okay, so the main objective of this research paper is to systematically review AI-driven user authentication modalities. Second, to categorize authentication approaches, biometric, behavioral, uh, psychological, and multimodal, and to compare methods using performance metrics that we are going to measure the performance metrics in accuracy, robustness, usability, and security purpose, and to analyze privacy risk, ethical challenges, and deployment limitations to identify future research directions. So, actually, we know the ever connected, suppose that the digital environment is becoming more hyper connected, and in this digital world, secure and reliable identity verification is central to security network. So, secure and reliable user authentication is one of the core necessities towards the security of the system on the internet and maintenance of the integrity of user interactions. So, conventional methods are inadequate against the modern cyber threats. So, actually, the AI has recently risen an effective facilitator in the field and can be seen as more accurate, adaptable, and usable than conventional methods. So, authentication techniques relying on machine learning, like facial recognition, voice recognition, and behavioral biometrics and anomaly detection. So, have been developed using machine learning to simulate complex user characteristics and independently low-level patterns in biometric or behavioral data. So another important thing that AI and machine learning became transformative technologies in the sphere and provide an opportunity to process huge amounts of identity-related data in real-time, identify anomalies, and constantly verify that including facial characteristics, voice, and fingerprints. So in this way, the role of AI and ML in identity verification and authentication in network environments is discussed in this paper as it continues to increase. And most important, that to explore the ways in which these technologies enhance space, precision, and robustness of the authentication system by using biometrics and behavioral analytical. So as well as dwells upon the, suppose we are talking about the issues of security, privacy, and ethical practices. So the proposed study examines the existing practice, practical issues, and emerging studies to offer an all-encompassing overview of all the AI-powered authentication, nature, and how it can be applied in its futures yes, in the context of network security system. Now, as per the we're talking about the literature survey, so there's a number of papers where it's found out, and we had to work out that now if you're talking about data about the system reviews is based on the systematic literature section. Okay, for example, the digital libraries, we can say that the studies only include those that deal with AI-based user authentication with empirical analysis, and those that lack technical validation or deal with the cryptographic authentication. So these strategies ensures relevance, quality, and reproducibility of the reviewed studies. So identification of the users is mandatory to make digital systems secure and confidential. So due to developing cyber threats, users are getting interested in how researchers employ artificial intelligence approaches to enhance the effectiveness of user authentication procedures. So in generally, WIF uses CNNs for the extraction of discriminative facial features in AI-based facial recognition and identity verification, though accurate and robust against several attacks. So its performance is highly dependent on high quality images and is still remains susceptible to adversarial manipulations. Fingerprint authentication has been improved with the inclusion of a number of machine learning models such as SVM, DBN, and as well as unique and user-friendly this may be. So latent fingerprints and spoofing are the potential risk of this. So when the face fingerprints and iris are integrated together, The multimodal biometric authentication improve its accuracy and exposing by the feature level or score level fusion. So compatibility in sensor and cost in computational still remains a challenge. So gate-based authentication employs deep learning for analysis of patterns of walking for non-institutive remote identification, and as well as deep learning based behavioral authentication trains the model on a large scale behavioral data set to learn unique patterns. So actually this is very true and can feed the changing users behavior. So keystroke dynamics can be performed using models such as HMM, and that could support non-intrusive continuous authentication. So dynamic authentication of the mouse passively with mouse learning algorithm, so including random forest is enabled by mouse of dynamics. So however, keystroke dynamics requires training by the use and it's sensitive to typing variations. Now, in another part that AI-driven mobile authentication system incorporate behavioral biometrics. So voice features and the face recognition using machine learning models to enable multi-factor authentication. So after this data storage, we have found out the number of gaps. So most of the some important gaps we have found out that the lack of standardized benchmark across authentication modalities and limited focus on privacy preserving learning, uh, federated and decentralized training. Third one is insufficient handling of algorithm bias and explainability of AI decision. So, and as well as fourth cap, we found out that high dependency on specialized hardware and large level data sets and poor cross-study reproducibility. So as per the result and discussion, we are talking that AI-based authentication outperforms traditional methods. So facial and voice recognition show highest accuracy. Third, behavioral biometrics enable continuous authentication. Fourth, multimodal system provide better robustness, resistance to spoofing, and performance varies based on dataset quality and evaluation protocol environmental conditions. So another major concern that biometric data privacy, user consent and acceptance, surveillance risk, bias in training data effects. So the main ethical aspects of AI-based authentication are associated with privacy. So demographic discrimination and conscious user consent. So due to unequal data sets may be disproportionately impactful on some groups of people, resulting in an unequal authentication process. So in addition, the mass biometric deployment also breed issues pertaining to the abuse of data and surveillance. So the solution is this issue involves privacy consciousness learning, bias sensitive model training, and the transparent governance system. The proposed solution is that the privacy preserving AI authentication using federated learning, differential privacy, multimodal fusion with explainable AI and standardized evaluation protocols. So conclusion, we can say that AI-driven authentication is a strong alternative to password. Second, offers higher security, usability, and adaptability. Third, addressing privacy, bias, and standardization is critical. And fourth one is the future system must balance security plus ethics plus user trust. So the in-depth research focuses on the significances of the AI techniques related to enhancing user authentication that ensures security in the digital system. So the review articles about the research showed various methods and their implications and limitations. So especially this method based on artificial intelligence offer high accuracy, continuous authentication, and multi-factor authentication. So these methods are observed through facial recognition, so fingerprint recognition, keystroke dynamics, gait recognition, and behavioral biometrics. So the merger of multiple modalities contributes to greater accuracy of authentication and withstands attack. So these are the references. Thank you.
Thank you, sir. Now I request our respected session chair, sir. Sir, do you have any questions?
Yes, Satish, nice
Yeah,
presentation.
yeah, thank you, sir.
Uh, can you tell me the how you are going to balance the security plus ethics and user trust as far as your research work is concerned?
Okay, sir. So actually, the recent works also actually privacy-focused learning paradigm like federated learning and differential privacy that allow learning a model without access to raw biometrics. So these methods ensure that there are no data leak acts, but do not affect authentication performance. So in addition, we are going to explainable AI technique are also being considered to enhance the transparency, equity, and user confidence in authentication judgments. So these strategies and their combination into an AI-driven authentication system is the way forward on the secure and ethical implementation in the future.
Okay, okay, good one.
Thank you, sir.
Karthik, yeah.
Thank you, sir. Now we'll be moving forward for the next presentation. For the next presentation, I like to call presentation Pavitra Balasubramaniam for the paper title An Optical Laser Link for Secure Data Transmission Using Arduino and Cybersecurity Integration. I request the presenter to kindly proceed with their presentation.
Hello, am I audible?
Yes, ma'am, you're audible.
Actually, I think there was a problem because our paper, Anushka Wadekar, that is me, and Pavitra were supposed to present. So I think there was some problem in the banner. Hello?
Mami, please continue with this. We'll get this sorted out in the background. Thank you.
Yeah, sure. Is my screen visible?
Yes, yes, madam. Please continue.
Yes, ma'am.
Yeah. So, good afternoon to the respected chair and to everyone present here today. I am Anushka Wadekar and I will be presenting our paper titled An Optical Laser Link for Secure Data Transmission along with Arduino and Cybersecurity Integration. Along with my co-author Pavitra Balasubramanian under the guidance of our Professor Anuradha Bakre at MIT WPU Pune. I will now briefly introduce the motivation, research gap and our proposed solution. So these are the contents of our presentation. Starting with the introduction, most modern communication systems today rely heavily on radio frequency based technologies such as Wi-Fi and Bluetooth. While these technologies are effective, but these systems are power intensive and costly and are also vulnerable to eavesdropping because radio frequency signals propagate in multiple directions. Laser based optical communication offers a strong alternative. It is highly directional, operates on a line of sight, and naturally limits unauthorized interception. So, our work explores a laser communication that is combined with encryption and a hardware level security system which helps in a low power and efficient data transmission system. While we were researching on this topic, we had narrowed down our objective to a single problem statement, that is, existing wireless communication technologies consume high power and are vulnerable to security threats, creating a need for a secure, energy efficient, and reliable data transmission system. We also discussed the impact, the gap in the existing systems, and the objective. Moving forward to the literature survey. So, out of the papers that we have researched in our research paper, these are the papers that had a very similar system to ours, and we have done a comparative analysis on these papers. So, the research gap that we noticed was that first and foremost, most of the communication systems that already exist today lack a integrated encryption and authentication system. Then, second, we noticed that the existing visible light communication systems are often complex and are not suitable for a low cost microcontroller like an Arduino, and they're quite difficult to program. So, third is that most of the radio frequency channels they use lightweight cryptographic techniques and have very limited exploration in the optical community. Additionally, many of these systems are sensitive to ambient light and lack synchronization and error handling. So this is our proposed solution. And finally, to address these challenges, we are yet to develop a secure laser-based communication system using Arduino Nano, that is the microcontroller that we will be using. So it consists of two main parts, the transmitter and the receiver. At the transmitter side, the textual data will be first encrypted using a lightweight cryptographic algorithm. And then this encrypted data will be then transmitted optically through two laser beams, one for the data signal and one for the clock signal, ensuring proper synchronization. And at the receiver side, the optical sensor LDR detects the incoming laser signals, and using the clock reference, the encrypted data will be accurately reconstructed, decrypted, and then displayed, or maybe it can be securely stored as we will be using a SD card. So, using combining these two directional laser transmission systems and an encryption method, our system provides a low cost and inference free data transmission channel. Now, the transmitter and receiver part will be further explained by Pavitra.
Good
Over to you.
afternoon, sir. Am I audible?
Yes, ma'am, you're clearly audible. Please continue.
Yes, sir. Yes, sir. This slide describes the transmitter part of a proposed system. So the primary function of the transmitter is to convert the digital data into secure optical signals for transmission. So at the transmitter, the data text is taken from a computer and is sent to the Arduino Nano. The Arduino will further process this data and will apply an encryption algorithm before transmission. For security, as she mentioned, we use standard cryptographic algorithms such as AES or DES, depending on the configuration. So AES and DES basically are symmetric key algorithms and will be activated only when transmitter and receiver sides have the same key. For example, 0101 both at the transmitter and receiver. This ensures that data is end-to-end encrypted and cannot be read by the third party if intercepted. So now, after encryption, the data is transmitted using laser diodes. To ensure accurate timing and synchronization, we use two separate laser signals, one for clock signal while the other one carries the encrypted data. The clock signal acts as a timing reference, allowing the receiver to correctly sample and reconstruct the transmitted bits. The encrypted information is finally transmitted as on and off laser pulses, forming a secure, interference free optical communication link. Moving on to the next slide. The signal flow process of transmitter module. In this flowchart, the message originates at the transmitter where the Arduino Nano converts the input text into binary form. The binary data is then secured using standard encryption algorithm, AES or DES. The encrypted data is transmitted using a laser diode where binary information is represented as on and off light pulses. Further, the authentication ID is appended the transmitter to ensure only an authorized receiver can decode and accept the message. Now we shall look at the receiver module. So this slide explains the receiver side of our system. The main function of the receiver is to capture the optical signals and securely reconstruct the original digital data. At the receiver side, the incoming laser signals are detected using optical sensors. So optical sensors basically convert the laser light into electrical signals, and in our prototype, we are using LDR-based photoresistor sensors for optical detection. So why LDRs, you may ask? Because they are low cost, easily available, and sufficient for demonstrating short range optical communication at initial stage of our prototype. For higher speed or long range implementation, photodiodes can be used instead of LDRs along with trans impedance amplifier to improve the response time and sensitivity. Since these signals are weak and may contain noise, they are first conditioned and cleaned before further processing. The conditioned signals are then sent to the Arduino Nano, which uses the clock to stay in sync and accurately read the data, reconstructing the encrypted binary information. The receiver then checks data for errors, decrypts it using the same key, and recovered message is either displayed or safely stored in SD card. Moving on to the block diagram of receiver. This flowchart explains how a received optical signal is processed at the receiver. Photoresistor sensors detect the incoming laser light and convert it to electrical signals. These signals are weak, therefore, signal conditioning is done using NPN transistor 2N3904 and resistors. The Arduino Nano, which will verify later on the device identity and will perform error detection using a software-based checksum or CRC, which is already implemented in the Arduino code. After verification, we get decrypted data using the same shared key as transmitter, and the recovered message is displayed or secured further. Moving on, the methodology slide. To sum up the whole system, the user gives text input, then it is encrypted, then laser transmission is done using clock and data pulse, then optical LDRs detect and convert to analog, then signal processing is followed, and then decryption is done. Finally, message stored for future analysis. So this is the result slide. This slide highlights the expected performance of a system. The laser communication link supports transmission range of up to 1.5 to 2 meters under indoor line of sight. Initially, the bit error is around 2 to 4% due to ambient light and timing mismatch, but this is significantly reduced by using a dual laser clock synchronization. The system achieves over 95% decoding accuracy under controlled lighting. Lightweight AES or DES encryption introduces negligible delay on the Arduino Nano, enabling real-time operation. Power consumption remains low, making the system suitable for continuous short-range use. Data integrity is ensured using checksum or CRC verification, and decryption messages are securely detained on the SD card for temporary or permanent uses. That was the presentation. Thank you.
Thank you, ma'am. I request respected session chair, sir. Sir, do you have any questions?
Yes. Nice. First of all, nice presentation, Anushka and Pavitra.
Thank you, sir.
Yeah, my first question is how you are saying that Arduino is best for communication system? Am I audible?
Yes, sir, you're audible.
Yes, sir.
Yeah, any one of you.
Can you repeat? Sorry, sir.
How you are saying that Arduino is best for communication system?
So, sir, Arduino is suitable for the communication of our systems because it supports the input-output control and the interfacing of these sensors or the LDR that we'll be using. The interfacing is going to be really easy with the help of Arduino, as the code is actually coding for an Arduino. We found out that it was easier for us. So the interfacing is going to be easier, and even the input-output control is going to be easy. That's why we can support the communication on Arduino.
Okay, another question is how you are providing the security as far as your system is concerned?
We will be now initially we'll be using AES or DS, which are like symmetric algorithms. So when the data will be transmitted from the transmitter to the receiver needs to put a password. Unless he has the key, he won't be able to see the data that will be transmitted. So that's how, even if there is an interruption in the communication, so that's how the person who is intercepting the data, they won't be able to see what actually the data is being transmitted. That's how we will be supporting the security thing that we are saying.
Okay, what is the new thing in your system which is not available in existing one?
Yes, sir. So, like I said in the research gap, the most important thing was that many laser communication systems exist, but they are not providing security, so that you won't be needing a key to access the data. Anyone with a receiver module can access it. So we are making an advancement by providing the cybersecurity algorithms in our system. So that's new.
Yeah, okay, done, Karthik.
Thank you, sir.
Excuse me, sir.
Thank you,
Actually,
sir.
I have a question related to this one.
Yeah,
Can I ask?
please, madam, you can.
Okay. Hello, Anushka. Narayani this side, and I am from IGDTUW. So my question is like that you have mentioned the range is 1.5 to 2 meter. Okay.
Yes, sir.
May I know the reason why we need a secure communication between a 1 to 2 meter? Because I think for a communication, it should be like wider range. for the secure one particularly?
Yes, ma'am, I get your concern, but right now, we just wanted to like for concept proof, we have used very low power lasers, which cannot be transmitted to like 3 or 4 meters. Actually, why we have integrated the cybersecurity is because nowadays a lot of advancements are being made in the satellite communication. So laser is being used to transmit data from one satellite to the other. And then for that scientific data, which is very important, we will be needing measures. And the laser communication that exists today does not have any security measures. And what we have thought as of now is that optical communication should be available to at a student level. So it should, if we increase the range of the transmission, then the cost will also increase, and then we will need advanced equipments. That's why for now we have just kept 1.5 to 2 meters, and then the security measures will be required when we increase the range, as you said. So
Okay, so laser signals can be affected by a simple component if it is placed between the light in that range. So, like for a satellite communication, also there if there is some interference, like the weather one, it will create a disturbance, right? And it is
yes,
very high in that part also. So,
yes,
you can explore the RF frequency one, and there's I think NIDAR. There are different kind of signals. You can
yes.
try these practical on that part, so it can be more practical, I think.
Yes, ma'am.
Maybe
Actually,
if
we have. I'm really
yeah.
sorry to interrupt you, but we have explored that as well. But for now, what we were thinking is that at radio frequency is a wave, right? So light is technically faster than radio
Mhm.
frequency. So in order to transmit the data really fast, that's why we were using light. But we can obviously explore the radio frequency, like you said as well. Thank you for your input.
Thank you so much. Actually, I'm also a student, so
Yeah,
I just want to know about that one.
yeah,
Okay. Thank you so
thank,
much, Anushka.
yeah. Thank you, ma'am.
Thank you, ma'am. Now we'll be moving towards next presentation. For the next presentation, I like to invite presenter Joginder Singh for the paper title Bibliometric Mapping of Employee Green Behavior and Organizational Sustainability 2018 to 2025. I request the presenter to kindly proceed with their presentation.
Good afternoon to all. Am I audible?
Yes, sir, you're clearly audible and your screen is
Yeah.
visible to
Yeah.
us. Please proceed.
Good afternoon, respected chair and distinguished participants. I am Joginder Grewal, and here to present my research titled Bibliometric Mapping of Employee Green Behavior and Organizational Sustainability from 2018 to 25. Uh, so I'm first the introduction about employee green behavior and organizational sustainability. So first of all, we need to understand the employee green behavior. Employee green behavior means the actions and practices of employees at a workplace that helps to protect the environment and supports organizational sustainability goals. And employee green behavior is a key area of research focus where organizations around the world focus on sustainability and environment stewardship. It is generally accepted in the literature that employee green behavior is a voluntary pro-environmental behavior of the employees that leads to organizational sustainability. These actions also involve energy saving, waste management, recycling of resources, and sustaining the organizational green policies that are essential in reducing the impact on the environment and increasing the corporate social responsibilities. And the organization's sustainability refers to an organization's ability to operate responsibly by balancing economic performance, environmental protection, and social well-being. It focuses on meeting the present needs without compromising the future generation through efficient resource use, ethical practices, and long-term strategic planning. The growing global awareness regarding the environmental issues cause organizations to focus on sustainability as an essential strategic goal. The green behavior of employees or activities that are discriminatory and environmentally friendly by employees at the workplace has become a key push factor toward the sustainability of organizations. These behaviors helps in minimizing resource uses, wastage, and corporate environmental responsibility projects. It is therefore important to learn the research seen on employees' green behavior in order to promote sustainable organizational behavior. The literature review on employee green behavior, green human resource management. Basically, nowadays, most of the organization are more focused on green environment. So, in this whole process, the employees play a very important role. So green human resource management practices are seen to be effective in facilitating employee green behavior, green recruitment, environmental training, environmentally friendly performance assessment, and rewards are the some of the initiatives that influence employees to adapt sustainability. One of the studies emphasized that transformational leadership and supervisory support increase employee engagement and green motivation. Empirical research shows that there is a dynamic interaction between the personal and organizational factors to promote employee green behavior. Sustainable practices depend on the environmental values of employees, their knowledge and education, and the supportive environment creates crucial leadership styles, communicated policies, and culture of organization, a green environment. Green practices at work are also supported by the psychological ownership and normal and moral norms of employees. Objectives of the studies are to conduct an efficient review of academic sources on green behavior of employees in promoting organization sustainability from between 2018 to 2025 using a bibliometric approach, to map trends of research and patterns of collaboration as well as intellectual frameworks in the area of employee green behavior and organization sustainability, to conduct science mapping to determine co-authorship, thematic clusters, and keyword occurrence representing research frontiers and collaboration networks. Research methodology. The study adopts a bibliometric research approach to systematically review academic literature on employee green behavior and organizational sustainability published between 2018 to 25, and quantitative bibliometric analysis was employed to map research trends, collaboration patterns, and intellectual structures in this domain. Data were collected through an extensive search of academic database, primarily Scoopers, using well-defined keywords such as employee green behavior, organizational sustainability, and green HRM. Only peer-reviewed journal articles, conference papers, and book chapters published in English during the specified period were included. The dataset was carefully screened and refined to remove duplicate and irrelevant records, ensure high data quality. Bibliometric attributes such as authorship, year of publication, country of origin, keywords, source titles, and citation counts were extracted and standardized. Performance analysis was conducted to evaluate research productivity using indicators like publication volume, citation impact, and prolific authors. Science mapping techniques were applied to identify co-authorship networks, keywords, co-occurrence patterns, and thematic clusters, revealing research frontiers and collaboration structures. Analytical tools such as viewers, and bibliometric R package were used for data analysis and visualization. Findings were presented through network maps and strategic diagrams to interpret the intellectual landscapes and emerging trends in the field. The methodology acknowledged limitations related to database dependency and language restrictions, which may exclude some relevant studies. Overall, the bibliometric approach provides a comprehensive understanding of the evaluation and dynamic of research on employee green behavior and offers valuable directions for future academic research and practical applications. Then data analysis tools. As earlier I have said, bibliometric, we have used two main software tools, viewers and bibliometric R package. Both are the open source tools. Viewer was used mainly for visualization, while bibliometric supported quantitative analysis. We applied two techniques. First, performance analysis, which include publication trends, citation impact, and identification of top authors. Second, science mapping, which helped us analyze co-authorship networks, keyword co-occurrence, and thematic clustering. The output of the analysis include network maps, strategic diagrams, and visualizations showing research collaboration and emerging themes. However, the study has some limitations. It relies only on indexed database, and language restrictions may have excluded relevant non-English studies. Bibliometric overview of employee green behavior research 2018 to 25. This dataset consists of 219 documents collected from 116 different sources. The field shows strong momentum with an annual growth rate of 22.21% of an average of 31.1 citation per document. A total of 685 authors contributed with an average of 3.6 co-authors per paper, indicating collaborative research. Nearly 47% of the publication involve international co-authorship, reflecting global research engagement. The dataset shows high thematic richness with 710 keywords and 580 keywords plus. Most documents are peer-reviewed articles highlighted in the academic rigor of the field. Then key journals, collaboration and geographic trends. Regarding publication sources, the journal Sustainability leads with 28 articles, followed by CSR and Environmental Management with 8 and with 10, and Business Strategy and Environment with 8 publications. The presence of interdisciplinary journals indicates a broad thematic scope of the research. The co-authorship network highlights key central authors such as Chaudhary, Islam, Ahmad, Afsar, and Ranner. The network structure shows strong clustering, suggesting active collaboration among research groups. At the country level, India emerges as the largest collaboration hub. Major collaborative links are observed with China, the United States, the United Kingdom, Pakistan, and Asia. Overall, the analysis shows Asia Pacific dominance with strong connections to Europe and North America. Intellectual and thematic structures. The keyword occurrence analysis reveals three major thematic clusters. The first cluster focuses on green HRM practices such as training, recruitment, and performance management. The second cluster relates to CSR and environmental performance, while the third emphasizes pro-environmental behavior and organizational culture. In terms of emerging trends, the analysis highlighting growing interest in green transformation leadership, ethical leadership, and environmental concern. Co-citation and bibliographic coupling result identifying a strong intellectual base with influential authors including Chaudhary, Ahmed, Afsar, Lee, and Wang. Key journals shaping in the field of sustainability, journals of cleaner production and CSR and employee environmental management. Overall, the research interdisciplinary, drawing insights from psychology, HRM, environmental sciences, and behavioral.
Sorry to interrupt, sir, but you have 1 minute to conclude. Thank you.
Okay, the findings are like the research topic is booming with the strong academic impetus. As I have told, almost 209 reports from 116 sources demonstrate the impressive growth of 22.21% annually, and the discipline shows that robust academic influence with an average of 31.1 citation per document. The sustainability research exhibits high collaboration patterns with 685 authors contributing an average of 3.6 co-authors per document. 46.89% of the research involves international partnerships, reflecting the global nature of sustainability research. The publication trends that are dramatic, with the number of articles rising from 28 to 57 annually, showing that the employee green behavior research has reached a critical mass following corporate sustainability efforts. And the thematic insights and research conclusion. The three major research clusters identified: green human resource management, organizational and employee behavior, and environmental performance and CSR. Authors and institutional networks, like influential authors are Chaudhary, Afsar Ahmad, and Islam. Institutional hubs like Sinchon University, Wang University, and sorry, the Chinese University of Hong Kong Business School. The bibliometric and co-authorship maps show a small world network, dense, interconnected, and efficient in knowledge dissemination. Global and cross-disciplinary reach, country from global north like USA, UK, Germany, and South India, Pakistan, Malaysia, and Central to collaborative networks. The suggestions for the future research is identifying the research gap, like sectoral gap, behavioral change, technological integration, and cross-cultural insights. Methodology recommendations: longitudinal design, capture evaluation and sustainability of green behavior, mixed method approach, experiential and quasi-experiential designs, and culturally validated tools. Thank you.
Thank you, sir. Now I request respective session chair, sir. Sir, do you have any questions?
Yes, Karthik. Joginder, nice presentation.
Thank you, sir.
Only one question from my end. How the performance analysis works as per as the publication and citation concern?
Pardon, sir?
How performance analysis works as far as publication and citation concern? You have mentioned one line in your PPT, right? Performance analysis regarding.
Performance, yeah. Through green HRM, we can assess the performance of the employees using the various tools.
How VOS viewer works? Joginder, are you there?
Yeah, sir.
Yeah, how VOS viewer works? Okay. Any questions from audience? Yeah, done, Karthik.
Okay, sir. There is another request to all the participants that you kindly adhere to the timings. That is 10 minutes for the presentation and 2 minutes for the question answer round. Now we will be moving forward with the next presentation. For the next presentation, I like to call presenter Nancy Pathak for the paper title Cross Architecture Assemble Learning for Enhanced Brain Tumor Identification. I request the presenter to kindly proceed with their presentation. I request the presenter to kindly proceed with their presentation. Okay. Now we'll be moving forward for the next presentation. For the next presentation, I like to call presenter Shilpa for the paper titled Deep Learning Based Food Recognition Using Transfer Learning on Benchmark Datasets, Comparative Analysis of CNN Architectures. I request the presenter to kindly proceed with their presentation. I request the presenter to kindly proceed with their presentation. Okay. Moving towards the next presenter. For the next presentation, I like to call presenter Narayani for the paper title Predicted Optimization for Digital Forensics Image Forgery Detection Using Fed Yogi with CNN and ResNet 50. I request the presenter to kindly proceed with their presentation.
Hello, sir. Narayani this side. So let me share my screen first.
Yes, ma'am. You can share the screen now.
Is it visible?
Yes, ma'am. It is totally visible.
Okay. So hello, everyone. My name is Narayani and I am from IGDTOW, Delhi. Just give me a second. Yes. Uh, so, my department is Information and Technology and paper ID 596. And topic is Federated Optimization for Digital Forensics and Image Forgery Detection using FedYogi with CNN and ResNet 50. So first, why I choose this one is because we have to identify the real and fake images. For that, uh, in a digital forensic domain, you will see digital images are widely used as legal and forensic evidence. So easy availability of editing tools make image forgery very common, and it is also cost effective, so anybody can tamper those images. So even a single image forged image can mislead the whole investigation into a different manner, and it can also mislead the whole investigation. So traditional forensic models rely on centralized data training, which you will see like GDPR and data protection law, and these kind of laws can uh, you know prevent these centralized data training. So if we want to train our models, it is a very challenging part to get data of these kind of things, and then we have to train our models, so it is a very challenging part. So that's why we are using a federated learning one. So it can also, you can say, we can train our model collaboratively and without sharing our data. So when we talk about a FedYogi, it can make our model very stable. So in a centralized learning, it can create a privacy issues, security, and legal concern. In FL, we are not sharing any type of raw data, which can help us to prevent those data leakage issues and to misuse those data. So in federated learning approach, we have seen these part to avoid sharing our raw data, but we can train our models. So our objective is to create a, you can say, to develop a privacy preserving and practical federated learning framework for image forgery detection that works effectively on non-IID forensic data. So non-IID means like we have a different labs. As you can see, we have a different labs and we have a central server. So we are not taking any data from them, but we can't expect everyone to have a same kind of data. Like one is a police lab, another one is a cybercrime lab, another one is you can think of a institution lab. So they can train a model but without sharing data, but we can't expect them to have a same kind of distribution, so they can have a same type of features. So that's why non-id data sets are very crucial to train on them, and it can also you know become very critical to train models and to get a proper model, a working model for all domains. So non-IID forensic data can make our models very unstable. That's why we are using FedYogi to ensure stable model convergence. Because when you will train model, you will see there are some fluctuations in your output. Like randomly, the accuracy will go up and then it will fall down, and the gradient will also be fluctuating. So avoid these things. We are using FedYogi, and then it can deliver robust detection performance across multiple organizations. As I have mentioned, we have a different kind of labs, and it is training data on their place and taking an update from these models. So that is the objective of our model, to prevent data and also make a practical use of this one. So as we can see, my motivation for this one is, like, we have seen many fake images and to mislead these things. Like in 2003 in Basra, during the invasion of Iraq, a British soldier was featured on the front page of the LA Times. So it can make a very political you know politically it can become very critical to share these kind of images, and it can create controversy. Similarly, in September 2009, one of the most popular singer in the United States, Kelly Clarkson, was digitally slimmed down and featured on the cover of Self magazine. So it can also create a self image kind of things. So people can mislead themselves. Nowadays, you are seeing many influencers are sharing their images, and that is very edited. Similarly, in a MACD image, also you can see if the image is taken and forged, it can create an impact, like people are expecting something else, and they are very challenging to identify like which one is a real one and which one is fake one. So we have seen manipulated images and deep fake images are increasing rapidly, undermining security, privacy, and sociality trust. In 2022, 66% of cybersecurity professionals reported deepfake related incident, a 30% increase from 2021. And when it becomes AI one, then it's changed from 704% like to identify these things. The image, whenever the increase in tools, it can also risk the data privacy and all. Like people were using ghibli arts to give their data and to train the models of ChatGPT on. So it can also create a privacy concern. So identifying these kind of images is a very critical thing. So by 2026, 30% of enterprises may consider standalone identification verification tool unreliable, because data our ML model are trained on a one type of data set. To identify these things are very critical. So non-IIT data set is a thing. When we train our model on non-IIT data set, it will have a different exposure, and it can detect different kind of images easily. That's why it is a part of a thing. So now manipulated images contribute to unrealistic beauty standard, misinformation, and distorted political discourse. So it was from a paper at Bal Colby 2023. So I have also pasted the link. So what are the impact of fake images, and what are the things if our images forged, and what can be the impact of it? So first one, this one is a case of Isdal woman. She's from Norway, and her mysterious death was the unsolved mystery from 1972. Like it was like I think last year also this case was reopened, and people are working on this one. So the challenge was victim deliberately used 8 different fake passports to check the authentication of that thing. All labels were removed from her clothing and preventing identification. Her, we can say directly, not her evidences were related to the image forgery, but it becomes like when it came to the identification part, it is very critical to identify those documents. So that's how it is connected to the image forgery one. These intentional identity manipulation left the case unsolved, highlighting the challenges of forensic investigation when false identities are used. So these are the few papers that we have read for our presentation. First one is a he et al. Is a 2016 paper, which is a ResNet enabling deep CNN for accurate image forensics face analysis, because we want to make our model reliable and work better. So when we use the CNN one, we saw there are only edge base, or you can say few features were extracted there. But when we used a ResNet 50, it because of the residual network, and it is taking all the features, you can say the image level detection was there. So McMahon also proposed the paper in 2017, federated learning approach, in that they have used fed average for decentralized training without sharing their data. So when we are talking about a fed average, it gives the all the type of data equally to average all their update. So when there is a non-ID data set, it
I'm
is
sorry
very
to
big.
interrupt, but you have 1 minute to conclude.
Okay, just give me. So these are the few papers. So in this one, you can say there are limitation of a image forgery detection non-ID data set. It can gives the client drift, or you can say federated learning, which can when we use the Fed Yogi, it gives the improved convergence stability. So our model can become better. So when we trained our model on a centralized one, the issue was it has to take the data at the central server, and then it has to train their models. So when we are using FedYogi, it uses a Fed aggregator with the adaptive formula, so it can change the learning rate and gradient updates, and it can make your model stably according to that one. So when it is taking about when we are talking about a privacy preserved forgery detection, it is training the models on each client and taking the update at a Fed Yogi optimizer, or you can say the at a server level. Then again this whole process is repeated for a 10 rounds. You can say whenever we can adjust that part according to the model updates. Then we observe these things, like what are the changes. We can see there are the few configuration that we have used. You can check this one, like we have taken 64 images because we have a large data set. And lastly, these are the result that we can say, like privacy was in ResNet 50, privacy was high and the model is very stable as compared to CNN1. And same when we train it on a centralized one, our model is not the private is not our data is not protected, but the model was working better. Similarly, for a ResNet 50 also, privacy was a concern there. So at last, we can say federated learning is a more practical approach for future works, and we will explore more adaptive learn federated optimizers in future, and it can become a more scalable, secure, and future ready foundation for trustworthy digital forensic analysis. So lastly, these are the few references that we have used for our paper. So thank you everyone. If you have any questions, you can ask. Hello, am I audible?
I request a respectful session. Yes, ma'am, you're totally audible. I ask a respectful session chair, sir. Sir, do you have any questions?
Yes. Narani, nice presentation.
Thank you so much, sir.
Only one question for you, that how your system is different than the existing one.
Yes, sir. So existing one are working on a face forgery, particularly on a face detection system, and it is using a Fed average. Means if we have a non-ID type of data set, like from a different labs, it will become unstable. Our model can give you the random updates. So that is a part, like for a longer time of investigation, like the case that I have mentioned is the one that was a 50-year case. Now if somebody wants to investigate that one, the model, if the model will change, then it should be a stable one, right? So it cannot give you a different output every time. That's how the FedYogi is making it more stable version, and to identify these kind of images, and with the adaptive learning, so it can train on a different type of data set.
Yeah.
So do you have a yes, sir?
Over to Karthik.
Thank you, sir. Thank you, ma'am. Now we'll be moving forward with the next presentation. For the next presentation, I like to call presenter Iduma for the paper title Image Classification Quantum Support using Quantum Support Vector Machine. I request the presenter to kindly proceed with their presentation.
Yes, sir. Am I audible?
Yes, ma'am, you're clearly audible and your screen is visible too.
Yes, sir.
Please proceed.
Okay. Thank you, sir. Good afternoon to everyone. My name is E. Induma. I'm doing a PhD under the guidance of Dr. Raghupati Rangasamy. The paper ID is 551. And the image title is Image Classification Using Quantum Support Vector Machine. The research focuses on QML model is used for image classification. It's an introduction. QML model integrates quantum computing principles with machine learning to handle high-dimensional image data. Classical models suffer from scalability issues and high-dimensional cost. QML models like QNN, QCNN, QC, QSVM is to improve the feature representation using quantum circuits. QSVM extends classical SVM by using quantum feature maps and quantum kernel computations in high-dimensional Hilbert space. QSVM is chosen because it's parameter efficient and suitable for NISQ devices and effective for image classifications. Moving to problem statement. and literature reports that classical image classification model struggles with scalability and high dimensional image data. A study shows that classical SVM helps high kernel computation and memory cost as a feature dimensional increases. Existing deep learning approaches require large parameter counts and extensive training data, leads to high dimensional overview. And literature identifies the need for effective, efficient, and evaluation for QSVM for image classification. Next, motivation. Quantum computing offers inherent parallelism through superposition, enabling efficient handling of high-dimensional image features. Entanglement allows quantum models to capture complex correlations among image pixels that are difficult for classical methods. QML can reduce the number of trainable parameters compared to deep classical networks. So hybrid quantum classical algorithms uses SVM, QSVM for compatible with current NISQ devices. Since recent works shows promising results, we are motivating to apply the QSVM for image classification. Next slide, theoretical background. Quantum computing uses a qubit. Qubit can exist in both 0 and 1 states using superposition. A superposition enables parallel processing of multiple computational states, and entanglement allows qubits to share the strong correlation between the qubits. And quantum gates such as Hadamard, rotation, and CNOT manipulate the qubit states through unitary operations. Quantum circuits perform computations, and finally, measurement produce the classical outputs. It's a classical support vector machine. SVM is a supervised learning algorithm, classifies the data by constructing an optimal separating hyperplane between classes. So SVM maximizes the margin between support vectors, resulting in strong generalization performance. The classical SVM optimization objective is formally expressed as min 1 by 2 W square and plus C sigma n I is equal to 1. And this SVM tries to minimize the normalization of W, which means that it tries to maximize the margin between two classes. So the kernel computation becomes expensive and slow. So high dimensional image data, kernel matrix computation, and memory requires image significantly and affects scalability. So this is the limitations of classical SVM motivate the development of quantum enhanced approaches such as QSVM. And the quantum support vector mission is a quantum enhanced extension of classical SVM that utilizes quantum feature maps to improve the class separability. It maps classical input image data to high dimensional Hilbert space, which a quantum feature map unitary pi of x. The quantum kernel functions like k x of I, pi xi and pi x2 some overall as a square root. The formula defines the quantum kernel which measures the similarity between two data samples, and pi of xi is a inner product between two quantum states. The squared we are using to overlap to get the value between 0 and 1. The kernel value is computed by executing quantum circuits and estimating the overlap between quantum states using measurement outcomes. The quantum kernels enables efficient mapping of data high-dimensional feature space, potentially enhancing class separability. The quantum kernels is evaluated on quantum device, which is similar to QSVM. Optimization is performed classically. By leveraging quantum superposition and entanglement, QSVM enables efficient kernel computation for complex and high-dimensional image data. Data preparation. We are using two data sets. One is SARS-CoV, two CT scan images, which is nothing but a COVID and non-COVID cases. has a 2481 grayscale images and a fashion MIC dataset height. We are using only two sets. One is top and t-shirts. It has a 14,000 images, which is used to which is selected to reduce the big of n square quantum kernel cost. All images are normalized to 0, 1, and each image is flattened into one-dimensional feature vector, so make it compatible with the classical and quantum models. CT images have 50,176 features, and the fashion MNIST dataset have 78 features. Pre-processing reduces the raw dimensionality and prepares the data for quantum feature embedding. First, images are resized to fixed dimension and converted into uniform format. So the data set, fashion MINC data set is a benchmark data set, and SARS COV2 CT split as 12,000 to 2,000 and 1,985 to 496. It has two classes. Here are also two classes. Just the top t-shirts and COVID and non-COVID. Resolution is 28 into 28 for fashion and 224 into 224 for CT scan image. Original features are 784 features and 50,000 features. Next, dimensional reduction and quantum encoding. Since we are having quantum hardware had limitations on number of qubits, so we are not able to directly apply the high dimensional image features into the quantum SVM. So we are applying a PCA for feature reduction before encoding. SARS images are reduced to 50,000 features to 8 principal components, and fashion MIST images from 784 to 8 components. Dimension reduction minimizes qubit requirements and enables execution on simulated hardware. Final features are scaled to 0 to 2 pi and encoded using angle encoding, mapping classical data to quantum rotational angles. Quantum feature maps. This explains how classical features are mapped into quantum features spacing using quantum circuits. Classical features are embedded using two layers, parameterized circuits, which each feature is encoded through a single qubit RY rotational gates. A circular chain of CNOT gate is employed to introduce entanglement to capture the correlation among input features. A feature map projects classical data into high-dimensional Hilbert space. Coming to the figure shows that classical features are encoded into qubits using rotational RY gate or rotational Y gate. Each gate has every gate has 8 bits, 8 qubits, which is represented in a RY gate, and we are using a CNOT gate. It creates an entanglement between qubits.
I'm sorry to interrupt, but you have 1 minute to conclude. Thank you.
Okay. Quantum circuits, QSEM framework quantum kernel matrix by repeatedly evaluating a parameterized quantum to estimate steps overlaps between data samples. 8 qubits and 8 PCA reduced features of both SARS and fashion MNST data sets. So coming to the figure, first we are reducing the data and features using PCA. We design an 8 qubit and 8 quantum circuit which quantum representation at features. First, you are having a 8 qubit here, 0 to 7. In that, first each feature is encoded into a circuit using RY gate. Is it a rotational Y gate through angle encoding? After encoding, we are applying a circular chain of CNOT gate to introduce entanglement between all qubits. This entanglement allows all circuits to capture correlations among features and increases the expressive powers. And using these circuits to capture the quantum kernel matrix by evaluating the overlap between quantum states. Finally, the output of the quantum state is used to capture quantum kernel by measuring the overlap between quantum circuits. Classical performance, it has performance of MNIST and CT scan images as 2.77 separation ratio, and here's a 1.24 ratio. There's a trained para performance is FN score as 0.87 for non-COVID and 0.86 for COVID. Data set has 0.95 for both classes. It shows a stable and strong learning. The test evaluation for facial MNIST is 0.93, and test evaluation for CT scan images is 0.77 over 496 test samples. Class-wise, it shows because visual representation is CT scans. Overall, this result shows that QSVM learns effectively in Q features phase and perform very strongly on facial MNIST datasets. Comparative analysis, QSVM performs systematically compared with classical SVM with a linear polynomial RBF and sigmoid kernels. QSVM outperforms 0.76 accuracy and SARS CT scan image 6.5 error reduction of 0.92 for facial MNIST, and it utilizes 59% on support vector counts and 490 support vector counts as 25%. Overall, QSVM demonstrate a competitive generalization and strong learning capability, particularly in complex feature spaces, highlighting the potential advantages the feature maps. The QSVM gives a better and compatibility accuracy than classical SVM and avoid overfitting by using the feature support vector versions. The conclusion, the QSVM leverages quantum computation principles to enhance the high-dimensional image classification by improving nonlinear features, and quantum kernel methods effectively map classical images into high-dimensional Hilbert space, while facial MNIST shows a strong efficiency gains compared to COVID. Comparatively, benchmark demonstrate the SVM matches outperforms on classical kernels, validating feasibility of quantum-enhanced learning on real datasets. High quantum kernel computations times approximately 3.3 hours. The bottleneck motivating future works is depending on hybrid quantum neural models. These are some references.
Now I request our respected session chair, sir. Sir, do you have any questions?
Yes, sir. First of all, nice presentation, Induma.
Thank you, sir.
What are the features of images you are considering to classify by using the QSVM?
8 features, sir. We are using
What
the
are
8
the
features.
features? What features?
It is a linear combination of PCA, sir. PCA will reduce the dimensions, sir.
And how many images are you are considering? That means what is the size of your data set?
Size of the data set is one is 14,000 and another one is 2,000, sir.
So have you applied the same kind of data set on QSVM
Yes, sir.
as well as SVM?
SVM, I applied, sir.
Because you are showing the comparative, right?
Yes, sir.
So on the base of that, you are getting the result like that.
Yes, sir.
Yeah, yeah. That's done, Karthik.
Okay, sir. Now we'll moving towards next presentation. For the next presentation, I like to call presenter Gopika for the paper title Optimizing Cloud Federation Performance, a deep reinforcement learning approach to cures and user experience. I request the presenter to kindly proceed with the presentation. Maybe ma'am is facing some network issues. Oh, she's back. Uh, I request presenter Gopika to kindly proceed with their presentation.
Good afternoon, everyone. My screen is visible to all of you.
Yes, ma'am, your screen is visible to us. Kindly proceed.
Okay, just a minute. Now the screen is visible in the
Yes, ma'am.
presentation mode.
Yes, ma'am.
Okay, thank you. So, very good afternoon to all of you. I am Gopika Fatehpurkar from the MIT ADT School of Computing, Loni Kharghar, Pune. So, today I am going to present here my paper, which is having the ID 663. The name of the title is Optimizing a Cloud Federation Performance, a Deep Reinforcement Learning Approach to QoS and the User Experience. So the main agenda uh, this is what is the problem statement and what are the different challenges I have come across. Then why I am using the deep reinforcement learning means what is my proposed system. Then what are the different research objectives and methodology. Then we will see the system architecture key components, experimental results and validation, then contribution and practical impact, conclusion and future directions. So here, what are the different challenges we are having in the cloud federation? So here we can say that the first main challenge in the cloud federation, as per my opinion, is whenever there are the multiple cloud service providers are there those services are taken by the different enterprises, and those enterprises are actually need to adapt the flexibility, and they also have to give the cost optimization. So it is the multi-cloud reality as per my knowledge. And the second one is the heterogeneity problem, where we can say that the each cloud service provider is having his own, their own architecture, own policies and own capabilities. Then dynamic demand, so as there are the day by day the number of cloud users are increased, so each cloud service providers are having the different type of the workloads. There is the problem in the resource allocations also. And major issue we can have in the network conditions, which is actually constantly changing. Then next is the QoS crisis, that is the quality of service crisis, where we can say the traditional static allocation is failing to maintain the consistent service quality. And the last challenge is user experience gap, where we can say there is the high latency and unpredictable performance effect at the end user. So these are some of the challenges. Then why we are going to why what is the problem with the existing solutions? So there is this problem. First, existing solution is actually using the rule based system, then it is using the machine learning regression models and the heuristic methods. So to overcome that, we are actually going to see the adaptive learning. So here we can see that the adaptive learning means it is learning the optimal policies through the continuous environment interaction. So real-time decisions are here we are making the different resource allocation choices instantly, which are based on the current state. And this algorithm again handle the uncertainty, that is the naturally manages the dynamic and unpredictable cloud conditions. And the last one is the autonomous optimization, where we can say it is continuously refines strategies without the manual interventions. So research objectives. So here are the some objectives. First, develop intelligent DRL, deep reinforcement learning framework for the dynamic resource allocation in the federated clouds. Then need to enhance or improve quality of service consistency across heterogeneous cloud platforms, reduce response time and improve the user experience metrics, create adaptive policies that handle real world cloud dynamics, and demonstrate scalability and practical applicability for the enterprises. So here is the basic architecture, which is of the DRL, that is the deep reinforcement learning algorithm, where it is actually having the state space, which is nothing but the cloud resources or the cloud work or the workload and the latencies. Then we can say that there is the DRL agent. That DRL agent is actually going to learn the different optimal policies, and according to that policies, by learning all those policies, it is going to take the action, and that action will be in the form of the resource allocation. So here are the some main components. That is, the first main component is the state representation. That is, it should be state what are the available resources, then what is the current workload, latency metrics, and the status of the different cloud service providers. Second, in the action space, we are going to do the resource allocation decision across the federated cloud service providers. And here, reward functions, that is the QoS metrics, response time reduction, and the user satisfaction. So all these key system components are bit aligned with the objectives. So these type of the main things we need to. Then this DRL algorithm policy gradient methods for the continuous optimization, and monitoring layer is real-time feedback for the policy refinement. So here, what is the learning workflow here? So first, as with respect to the architecture, here first we need to monitor state continuously, cloud state continuously, then decide the resource allocation, that is nothing but the action, then execute allocation decisions, and next one, fourth step will be the observe outcomes and collect the rewards, and the last, refine policy based on this feedback. So in the experiment evaluation, the data sets multi-cloud workload traces with the varying demand patterns, baselines, rule-based allocation, random allocation, and the heuristic metrics. And the metrics is having the response time and QoS. So here I would like to explain that. So whenever we are applying the adaptive decision making process, and it is actually used to reduce the latency more often, but to make the workload distribution more equitable, and increase the resource utilization as compared to heuristic and the static scheduling method of the traditional type. So the learning model which shows the stable conversion, and it is capable of adapting the changes. And basically finding represents the clear indication that the intelligent learning driven
I'm sorry to
strategy is.
interrupt. but you have 1 minute to conclude.
Okay. And the key findings here, resource utilization. So here, the resource utilization is increased by to 25%. Quality of service compliance is 98% plus SLA, and response time is actually decreased as per the traditional methods. And scalability and robustness. This is the heterogeneous cloud which successfully manages diverse provider architecture and policies. Dynamic adaptation, which responds effectively to workload spikes and changing conditions. Then fault tolerance, which is fallback mechanisms, ensure graceful degradation, and continuous learning is improve performance over the time with online refinement. So here are some contributions to novel DRL framework for the federated cloud optimization, technically adaptive resource allocation, then practically enterprise ready solution, reduce response time and quality, improve the QoS. Innovation is here, we can say the first intelligent approach replacing the static rule in the cloud federation. So real world impact here, we can say that for the enterprises, efficient multi-cloud operations, cost saving and improved app performance. And the for cloud service provider, it can, I can say that it is enhanced competitiveness, customer satisfaction and operational efficiency. So limitations and the future work. Current focus is mainly on the virtualized cloud environment. Next step is the production deployment validation and hybrid DRL traditional approaches. Expansion in integration with neurosymbolic AI and energy efficiency optimization and applications extension to IoT and wireless sensor network in the cloud federation. Main take key aways are the problem. Cloud federation need intelligent resource management. Solution DRL is enabling the adaptive and real-time optimization. Impact, I can say, significant improvement in the QoS and user experience. Vision is AI-driven cloud federation is the future of enterprise computing. Thank you.
I request the
Nice,
session chair, sir.
nice presentation, Gopika.
Thank you, sir.
Okay, what data set you're using?
Actually, the data set is actually related to the different cloud service providers, and they are having the what type of the workloads they are using and what type of the services they are providing, how much customers they are having, and how they are dealing with the infra related to that.
And how adaptive learning is used in your system? What is the role? What is the role of adaptive learning as far as your system is concerned?
Okay, so for the adaptive learning, so adaptive learning will be in the here in architecture itself we can see that. So actually there we are combining the two different algorithms, that is the deep learning algorithm and the reinforcement algorithm. So combining these both algorithms, I can see that here the adaptive learning adaptiveness means we can see here. Sorry, currently I'm not getting.
Okay, it's okay. Okay. Any questions from audience? Any questions from audience? Okay, over to Karthik.
Thank you, sir. Now we will moving towards next presentation. For the next presentation, I like to call presenter Praharsh for the paper title A Comprehensive Review of EEG based Brain Computer Interface Systems. I request the presenter to kindly proceed with their presentation.
Good afternoon, everyone. I'm extremely sorry about the previous delay caused on my side. I just share my screen right.
No problem, sir. You can please proceed.
Is my screen visible, sir?
Yes, sir. Your screen is visible.
All right. Um, so, good afternoon, respected chairman and fellow presenters. I am Prahash Bhonde from the Department of Computer Engineering, International Institute of Information Technology, and I'm working under the guidance of Dr. Pratiksha Choksi. Today, I will be presenting our work on EEG-based brain-computer interface interaction, where we focus on building a proof of concept EEG-based pipeline, and we study how brain signals can be translated into real-time computer commands. So here is the agenda. I will briefly cover all these topics quickly. So moving on. Right. Um, so brain-computer interface or BCI, it is a technology that establishes a direct communication pathway between the human brain and an external system. That can be anything. It can be a computer, prosthetic, any assistive device. Um, One of the most widely adopted approaches in non-invasive BCI is electroencephalography or EEG, where basically the brain's electrical activity is recorded using electrodes placed on the skull. So this is completely non-invasive. It is that's why it's widely used. What makes BCIs important is that they can bypass conventional output pathways such as speech or muscle movement. Instead, they interpret a user's intent directly through brain signals. So, if we say in simple terms, BCI allows a person to control a device without physically moving by decoding patterns from EEG or your brain signals. Uh, so, um, so our project focuses on developing an EEG-based BCI system for interactive applications. The pipeline we explore follows a standard BCI workflow. We use an EEG signal acquisition. We perform that using a variable device. Then we perform pre-processing to remove noise and artifacts. Then we undergo feature extraction, where meaningful patterns from the user signals are derived. Then classification is undergone, where we map brain patterns to specific commands. And finally, after all of that, real-time interaction, such as controlling cursor movement or triggering actions. So this is the real output that is achieved by reading, recording, and analyzing the brain signals. Um, Motivation. Sorry. The motivation behind this project lies in the growing role of EEG-based BCIs in there are various domains such as healthcare, assistive technologies, and human-computer interaction. For people with severe motor disabilities, traditional devices like keyboards, mouse, and touch interfaces become inaccessible. So BCI offers a potential solution by enabling direct communication between the brain and external devices, which improves independence and the quality of life for such people. From an academic and engineering perspective, this product also gives us a valuable practical exposure to signal processing, machine learning, and real-time system design, all within a high impact and emerging technology space. So it is very upcoming and booming, and it has a lot of potential. So that's why we thought that in order to make a maximum impact, we chose to go with this project. So here is our literature survey. We have referred to these papers and many more, but these are the main base papers based on which we try to draft this review paper. Uh, So we review such multiple papers, and the literature from these papers highlight that current DCI systems rely heavily on robust pre-processing techniques, effective feature extraction such as PSD and CSP. These PSD, that is power spectrum dimensionality, and CSP, common spatial patterns. So these algorithms help us with classification of the different types of EEG signals. And increasingly, we are also using deep learning models like CNNs and LSTMs for motor imagery classification. So again, these are also very commonly used deep learning models. They help with spatial and temporal analysis of the data. Um, Next, the main problem is that individuals with severe motor disabilities cannot use conventional interfaces. So, we would like to design a prototype EEG based BCI system that can acquire EEG signals non-invasively, pre-process and extract features, classify user intent, and translate it into basic human computer interaction commands. So essentially, we we aim to show that even with minimal resources, it is possible to create a functional and meaningful interaction system using EEG. So here's our existing system that we have built. We examined existing BCI solutions into two categories: uh, medical and assistive systems, such as the P300 speller, which enables typing through brain responses. This uses the SSVEP algorithm, steady state visual evoke potential. It is a medical grade device. It is highly expensive. And then there is the consumer grade EEG products, which we are trying to break through. Emotive Epoch or Insight, NeuroSky Mindwave, these are few examples. These devices do make BCI more accessible, but challenges still remain, including cost for higher end systems and limited accuracy for low cost headsets. This gap inspired our approach to build a low cost, minimal electrode prototype focusing on practical interaction. So here's a proposed system, this system we tried to build. Our key innovation is based on three main ideas. Firstly, it would be low-cost BCI. Instead of using expensive medical EEG headsets, we aim to use an affordable DIY EEG kit for real-time thought-based interaction. Secondly, minimal electrode setup. We target cursor navigation with only three electrodes while still enabling meaningful control, such as four directions and click. So with minimal electrodes, we're trying to extract as much maximum output as we can. Third, accessible human-computer interaction. The system is designed as a lightweight prototype that can demonstrate assistive potential using limited resources, making it scalable and practical. Then here are the challenges faced. So since this is a very upcoming field, there are still a lot of unaddressed challenges that still exist. Some of these are, give me a second. Right. So low signal to noise ratio. So EEG signals are weak and are easily affected by eye blinks, muscle movement, and environmental noise. So a key challenge is to extract meaningful and clean signals. Then high variability exists. So EEG patterns differ across users and sessions. So this requires a lot of recalibration since everyone's brain has their own unique characteristics. So the EEG signals also vary as such. Then we also have the issue of calibration time and BCI illiteracy. Um, so some users may struggle to produce clearly separable EEG patterns. This reduces performance, and since again there are many distinct BCI signals, we need increased calibration time in order to adapt to this challenge. So here's our architecture diagram for the system architecture. So the flow is that EEG signals are acquired from the wearable device using the acquisition layer. We place electrodes
Sorry to
which
interrupt,
are
sir, but you have 1 minute to conclude.
right. Thank you. I'm sorry. Um, So here's the acquisition layer. Here the data is acquired using electrodes processed through proprietary hardware, BioAmp band, and Arduino board. After that, we move on to the pre-processing layer where data is pre-processed, it is filtered, and only the meaningful frequency of EG bands, that is between 0.5 and 50 hertz, only that is extracted. After that, we move on to the feature extraction layer, where we try to extract meaningful data from this obtained recorded data. We use band power calculation and feature engineering is also done here. We are still in the process of implementing this completely, but currently it's going on. Once the features are extracted carefully and correctly, we move on to classification layer where we use deep learning models such as CNN, LSTM, and we can also use SVMs, support vector machines. These models allow us to classify signals effectively, and we can use this to detect user intent. And finally, based upon these signals that we have classified, we map them to an actual output, any physical external output, and this allows the user to control external systems using their brain signals. Um, so here are the project applications. So the most direct is assistive computer navigation. It enables users to move the cursor, click, open apps, and navigate without any physical movement. It can also support communication aids, where users can operate on-screen keyboards and AAC software. Another major application is smart home control, allowing users to control lights or appliances. Additionally, this can also support gaming and entertainment and serves as a groundwork for advanced control like robotic arms or powered wheelchairs. And so to conclude, our project focuses on building a proof of concept EEG-based BCI interaction system that helps translate brain signals into simple control commands. Uh, it provides so future extensions of the work. This may involve expanding to more complex hardware, complex control tasks, improving the classification accuracy, and trying to extract even more complex outputs from the user instead of simple commands. Uh, and so here are the references based upon which we have drafted our review paper. Um, Thank you for your time and thank you for letting me present. Any questions, sir?
Yeah, nice presentation, Prash.
Thank you, sir.
Okay, what features extracting as far as BCI concerned?
Okay. So the features that we are trying to extract, they would be the different types of EEG signals. So if you look at the different types of EEG signals, there are five different bands. We have delta, theta, alpha, beta, and gamma. And all of these bands, obviously, they show different behaviors. So we will be focusing on alpha and beta waves, which are basically the waves. Alpha waves are when your eyes are closed but you're still awake when you're like focusing. Beta is when your eyes are open, you're thinking, and then gamma is the highest frequency. But we will be focusing on alpha and beta since these are the most relevant. And these are the features that we are trying to analyze, detect patterns using simple hardware so as to accurately try to record user intent. So these are the features that we are trying to extract from
How
all the
your
noise
system?
and all these things. Yeah.
Okay, how your system is better than the existing one?
Right. So there are many existing systems out there, but they are not so accessible. Either they are too high of a cost, or they are facing some accuracy issues. So we are trying to bridge that gap. We are trying to make a system that is much less costly than these systems, existing systems, and we are trying to make the BCI much more accessible to all sorts of people by bridging this gap. So we are trying to focus on creating a low-cost system that will also improve accuracy. Uh, so yes, this would be the different. Yeah.
Yeah. Okay. Thank you. Thank you. Karthik.
Thank you.
Thank you, sir. Now we'll be moving forward for the next presentation. For the next presentation, I'd like to invite presenter Nancy Pathak for the paper title Cross Architecture Ensemble Learning for Enhanced Brain Tumor Identification. I request the presenter to kindly proceed with their presentation.
Thank you so much, Karthik. Yeah. Good afternoon, everyone. I'm presenting our work titled Cross Architecture in Ensemble Learning for Enhanced Brain Tumor Identification. So, this work was carried out by Nancy Pathak, Soumya Gupta, Gungun Singh, and Shruti Goyal under supervision of Dr. Ritika Kumari. So, I'll start with the introduction, then literature review, and then I'll explain our methodology, followed by results, and finally conclude with the future directions. Brain tumors are life threatening, and early accurate diagnosis is crucial for patient survival. So, deep learning models like CNNs and transformers have shown promise in MRI analysis. However, tumor appearance vary significantly in size, texture, and location, making single model predictions unstable. Most existing studies rely on individual architectures, and very few explore ensemble learning, especially stacking for brain tumor classification. To address this gap, we propose a hierarchical ensemble framework that combines CNNs and transformers using meta learning, enabling the model to adaptively trust the best architecture for each case. Prior research has focused on CNNs like ResNet and VGG, and more recently on transformers such as VIT and SWIN. However, most works evaluate models independently, so there is a clear research gap in systematic comparison and intelligent stacking of CNNs and transformers for brain tumor MRI classification. This is what our work addresses. So, for our methodology, our pipeline consists of data preprocessing, training four diverse base models, and combining them using ensemble learning, particularly stacking with meta learners. So we use the brain tumor MRI dataset from Kaggle with 7,023 images across four classes: glioma, meningioma, pituitary, and no tumor. Preprocessing included brain extraction, resizing to 224 into 224 to ensure they match the input requirements of pre-trained models, normalization, and RGB conversion. This ensures that the models focus on meaningful anatomical features rather than the background noise. Then for the base models, we used ResNet 50, VGG16, Vision Transformer, and Swin Transformer. We trained four architectures to ensure diversity. ResNet 50 captures deep hierarchical features. VG16 excels at feature extractions, and Vision Transformer models global dependencies, whereas Swin Transformer balances the local and global attention. This architectural diversity is essential for effective ensemble learning. We first tested traditional ensembles like averaging, voting, and weighted combination. Then we applied stacking, where outputs from all base models are combined into meta features and passed to a meta learner. So we used logistic regression, neural network, and random forest as our meta learners. So, like unlike fixed weights, stacking learns which model to trust for each specific input, making it adaptive and robust. So this is a summarized flow of methodology through a chart. And as for our experimental setup, all experiments were conducted using TensorFlow and scikit-learn on an NVIDIA Tesla V100 GPU, enabling efficient training and evaluation. So these are our results through some charts. We have shown the accuracies and confusion matrices. So among the individual models, VGG16 achieved the highest accuracy at 96.0 96.96%. Transformers performed slightly lower due to dataset size, but they captured complementary patterns which proved valuable in ensemble learning. So traditional ensemble achieved around 90% accuracy, actually underperforming VG16. So the random forest meta learner achieved 97.41% accuracy, outperforming all individual models and simple ensembles. This confirms that the intelligent and adaptive and combination is more effective than fixed averaging. So this is a list where we have listed down all the accuracies where meta RF is giving the highest accuracy among all the models. So yeah, for the conclusion, so I would like to conclude that we demonstrated that hierarchical stacking of CNNs and transformers significantly improves brain tumor classification. Our random forest based ensemble achieved 97.41% accuracy, proving that architectural diversity combined with meta learning outperforms individual models. And for the future work, it includes like adding explainability tools like GradCam, extending to tumor segmentation, and validating the framework on multi-center clinical datasets. So, thank you for your attention.
Okay.
I'll
Next
be happy to
presentation,
take up any
Nancy.
questions. Yes.
Presentation, Nancy.
Yeah.
Why you choose the VGG16 and ResNet 50 only? Why not other models?
Sorry, can you repeat the question?
Why you use the VGG16 and
Hmm.
ResNet 50 model only? Why not other models?
Like because these two represent like VG16 is known for its simple and uniform architecture using stacked 10 to 3 convolution filters, and whereas ResNet introduced residual skip connections, like allowing much deeper feature learning without vanishing gradient problems. So our goal was diversity. So including too many similar CNN architectures maybe can increase the redundancy. That's why we focused on making it more diverse, and that's why we chose VG60 and ResNet 50. Basically, more texture-based focused analysis.
Okay, what are the research gap you found while going through the different literature survey?
Yeah, so in the papers that we have reviewed, the most of the work was carried out like including like single based architectures, like none have included the stacking based approach where we are taking different base learning models. So here in our work we added more base learning models to see that how it is performing on various models.
Yeah, okay.
Any further questions, sir?
No.
Okay. Now we'll be moving towards the next presentation. For the next presentation, I like to call presenter Shilpa for the paper title Deep Learning Based Food Recognition Using Transfer Learning on Benchmark Dataset Comparative Analysis of CNN Architectures. I request the presenter to kindly proceed with their presentation. So the presenter is not present in the meeting. Shall we move towards a closing remark?
Yes.
Okay. Thank you. Now we'll be moving towards a closing remark. I sincerely thank the author for the excellent presentation and contribution in the session, and all the participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during the 10th version and all the previous 9th versions of the conference. We'll be happy to have you in 11th version in 2027. All the presenters will be getting their digital certificates within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of SmartCom 2026. I also thank our session chair, Dr. Ganesh, for chairing the session. Sir, this is a token of love and appreciation from the team of SmartCom 2026 and Global Knowledge Research Foundation and partners.
Yeah, thank you, Karthik. Thank you very much, and thank you, organizers.
Thank you, sir, for such valuable words and time. Now, I request everyone to kindly turn on their cameras for a quick virtual snapshot. I kindly request everyone to kindly turn on their cameras for a quick virtual snapshot. Thank you, everyone. Have a nice day.